View IP address settings. The ipconfig command can be used in a command prompt window to show the IP4 and IP6 IP addresses assigned to all network connections. See Figure 1511. Notice in the figure the 4 IP addresses that have been assigned to the physical connections. Windows has assigned the wireless connection to IP addresses, one using IP4 and one using IP6. The Ethernet LAN connection has also been assigned an IP4 address and an IP6 address. The IP6 addresses are followed by a %sign and a number. For example, %13 follows the FireST IP address. This number is called the Zone ID or Scope ID and is used to identify the interface in a list of interfaces for this computer. IP6 addressing is designed so that a computer can auto-configure its own link local IP address, which is similar to how IP4 uses an automatic private IP address, a PIPA. Here's what happens when a computer using IP6 FireST makes a network connection. 1. The computer creates its IP6 address by using the FE80:/64 prefix and randomly generating an interface ID for the last 64 bits. 2. It then performs a duplicate address detection process to make sure its IP address is unique on the network. 3. Next, it asks if a router is present on the network to provide configuration information. If a router responds with DHCP information, the computer uses whatever information this might be, such as the IP addresses of DNS servers or its own IP address. Because a computer can generate its own link local IP address, a DHCP v6 server usually serves up only global IP6 addresses. Character-based names identify computers and networks. Remembering an IP address is not always easy, so character-based names are used to substitute for IP addresses. Here are the possibilities. A host name, also called a computer name, is the name of a computer and can be used in place of its IP address. Examples of host names are www, FTP, Gene's Computer, TestBox3, and Pink Laptop. You assign a host name to a computer when you FireST configure it for a network connection. The name can have up to 63 characters, including letters, numbers, and special characters. On a local network, you can use the computer name in the place of an IP address to identify a computer. To find out and change the computer name in Windows 7/Vista, click Start, right-click Computer, and select Properties from the shortcut menu. In the System window, click Advanced System Settings. In the System Properties box, click the Computer Name tab, see Figure 1512. To rename a computer, click Change. For XP, click Start, right-click My Computer, and select Properties from the shortcut menu. Then click the Computer Name tab. A workgroup is a group of computers on a peer-to-peer network that are sharing resources. The workgroup name assigned to this group is only recognized within the local network. A domain name identifies a network. Examples of domain names are the names that appear before the period in Microsoft.com, Course.com, and mycompany.com. The letters after the period are called the top-level domain and tell you something about the domain. Examples are com, commercial, org, nonprofit, gov, government, and info, general use. A fully qualified domain name, FQDN, identifies a computer and the network to which it belongs. An example of an FQDN is www.course.com. The host name is www, a web server, Course is the domain name, and com is the top-level domain name of the Course Technology Network. Another FQDN is joesmith.mycompany.com. On the Internet, a fully qualified domain name must be associated with an IP address before this computer can be found. This process of associating a character-based name with an IP address is called name resolution. The DNS, Domain Name System or Domain Name Service, protocol is used by a DNS server to find an IP address for a computer when the fully qualified domain name is known. Your ISP is responsible for providing you access to one or more DNS servers as part of the service it provides for Internet access. When a Web hosting site FireSD sets up your website, IP address, and domain name. It is responsible for entering the name resolution information into its primary DNS server. This server can present the information to other DNS servers on the web and is called the authoritative name server for your site. When Windows is trying to resolve a computer name to an IP address, FireSD looks in the DNS cache it holds in memory. Information in this cache includes what it loaded at startup from the host's file in the c:\windows/system32/drivers/etc. folder. This file, which has no file extension, contains computer names and their associated IP addresses on the local network. An administrator is responsible for manually editing the host's file when the association is needed on the local network. If the computer name is not found in the host file, Windows then turns to a DNS server if it has the IP address of the server. When Windows queries the DNS server for a name resolution, it is called the DNS client. TCP/IP protocol layers. Recall that a protocol is an agreed-to set of rules for communication between two parties. Operating systems and client-server applications on the Internet all use protocols that are supported by TCP/IP. The left side of Figure 1514 shows these different layers of protocols and how they relate to one another. As you read this section, this figure can serve as your roadmap to the different protocols. In the following sections, the more significant applications and operating system protocols are introduced. However, you should know that the TCP/IP protocol suite includes more protocols than just those mentioned in this chapter, only some of them are shown in Figure 1514. TCP/IP protocols used by the OS. Looking back at Figure 1514, you can see three layers of protocols between the applications and the hardware protocols. These three layers make up the heart of TCP/IP communication. In the figure, TCP or UDP manages communication with the application's protocols above them as well as the protocols shown underneath TCP and UDP, which control communication on the network. Remember that all communication on a network happens by way of packets delivered from one location on the network to another. In TCP/IP, the protocol that guarantees packet delivery is TCP, Transmission Control Protocol. TCP makes a connection, checks whether the data is received, and resends it if it is not. TCP is, therefore, called a connection-oriented protocol. TCP is used by applications such as web browsers and email. Guaranteed delivery takes longer and is used when it is important to know that the data reached its destination. For TCP to guarantee delivery, it uses protocols at the IP layer to establish a session between client and server to verify that communication has taken place. When a TCP packet reaches its destination, an acknowledgement is sent back to the source, see Figure 1515. If the source TCP does not receive the acknowledgement, it resends the data or passes an error message back to the higher level application protocol. On the other hand, UDP, User Datagram Protocol, does not guarantee delivery by FireSD connecting and checking whether data is received. Thus, UDP is called a connectionless protocol or best effort protocol. UDP is used for broadcasting, such as streaming video or sound over the web, where guaranteed delivery is not as important as fast transmission. UDP is also used to monitor network traffic. TCP/IP protocols used by applications. Some common applications that use the Internet are web browsers, email, chat, FTP, Telnet, remote desktop, and remote assistance. Here is a bit of information about several of the protocols used by these and other applications. HTTP. HTTP, Hypertext Transfer Protocol, is the protocol used for the World Wide Web and used by web browsers and web servers to communicate. You can see when a browser is using this protocol by looking for HTTP at the beginning of a URL in the address bar of a browser, such as www.microsoft.com. HTTPS. HTTP Secure, is the HTTP protocol working with a security protocol such as Secure Sockets Layer, SSL, or Transport Layer Security, TLS, which is better than SSL. To create a secured socket, HTTPS is used by web browsers and servers to encrypt the data before it is sent and then decrypt it before the data is processed. To know a secured protocol is being used, look for HTTPS in the URL, as in www.wellsfargo.com. SMTP. SMTP, Simple Mail Transfer Protocol, is used to send an email message to its destination, see Figure 1516. An improved version of SMTP is SMTP Authentication. This protocol is used to authenticate a user to an email server when the email client FireSD tries to connect to the email server to send email. Using SMTP Auth, an extra dialogue between the client and server happens before the client can fully connect that proves the client is authorized to use the service. After authentication, the client can then send email to the email server. The email server that takes care of sending email messages, using the SMTP protocol, is often referred to as the SMTP server. POP and IMAP. After an email message arrives at the destination email server, it remains there until the recipient requests delivery. The recipient's email server uses one of two protocols to deliver the message: POP3, Postoffice Protocol, version 3, or IMAP 4, Internet Message Access Protocol, version 4. Using POP, email is downloaded to the client computer. Using IMAP, the client application manages the email stored on the server. Telnet. The Telnet protocol is used by the Telnet client, server applications to allow an administrator or other user to control a computer remotely. Telnet is not considered secure because transmissions in Telnet are not encrypted. LDAP. Lightweight Directory Access Protocol, LDAP, is used by various client applications when the application needs to query a database. For example, an email client on a corporate network might query a database that contains the email addresses for all employees. Another example is when an application looks for a printer by querying a database of printers supported by an organization on the corporate network or internet. Data sent and received using the LDAP protocol is not encrypted, therefore, an encryption layer is sometimes added to LDAP transmissions. SMB. Server Message Block, SMB, is the protocol used by Windows to share file A and printers on as a network. FTP. FTP, File Transfer Protocol, is used to transfer file A between two computers. Web browsers can use the protocol. Also, special FTP client software such as Qt FTP by GlobalScape, www.qteeth.com, can be used, which offers more features for file transfer than does a browser. To use FTP in Internet Explorer Version 9, enter the address of an FTP site in the address box, for example, ftp.cengage.com. A logon dialog box appears where you can enter a username and password, see Figure 1517. When you click Log On, you can see folders on the FTP site and the FTP protocol displays in the address bar, as in ftp.cengage.com. It's easier to use Windows Explorer to transfer file A rather than Internet Explorer. After you have located the FTP site, to use Windows Explorer for file transfers, press Alt, which causes the menu bar to appear. In the menu bar, click View, open FTP site in Windows Explorer, see Figure 1518. Then click Allow in the Internet Explorer security box. Windows Explorer opens, showing file A and folders on the FTP site. You can copy and paste file A and folders from your computer to the site. SSH. The Secure Shell, SSH, protocol is used to pass login information to a remote computer and control that computer over a network. Transmissions are encrypted so they cannot be intercepted by a hacker. SFTP. Secure FTP, SFTP, is used to transfer file A from an FTP server to an FTP client using encryption. The encryption layer of the protocol used by Secure FTP is a variation of the SSH, Secure Shell, protocol. SNMP. Simple Network Management Protocol, SNMP, is used to monitor network traffic. It is used by the Microsoft SNMP agent application that monitors traffic on a network and helps balance that traffic. RDP. Remote Desktop Protocol, RDP, is used by the Windows Remote Desktop and Remote Assistance utilities to connect to and control a remote computer. Recall that client, server applications use ports to address each other. Table 15.5 lists the port assignments for common application. Now that you have an understanding of TCP/IP and Windows networking, let's apply that knowledge to making network connections. That will be all for this video, so be sure to hit that like button and subscribe to CTech and enable that bell icon so you don't miss any further videos with us.